Hey everybody, and welcome to how to add and subtract rational expressions. So in a previous video, we figured out how to find the LCD of rational expressions and rational functions. Now what we're going to do is we're going to use what we know about the LCD to help us combine rational expressions together. So we're still not solving anything, we just want to combine. Okay, think of adding and subtracting as combining. Okay, but just like in fractions, right, we can't combine fractions together that have mismatching denominators, right? What do we have to do? We have to create a common denominator, and then we add or subtract our numerators, and then we have our new combined fraction. We're going to do the exact same thing here today. It's just we're going to have a couple of variables floating around, and we're going to look at polynomials and kind of how to do that when we have a polynomial over a polynomial instead of just a constant over a constant. Okay, but you'll see the concepts look exactly the same. So how is this done? So let's do a quick review. So first, if your rational expression is not simplified, simplify it to make your life easier. Sometimes you can knock some stuff out and deal with a simple irrational instead of a more complex one. Step 2, find the LCD. So we need to find the least common denominator for every rational expression that we have, which just means really every term. We need to find the LCD here of every single term. And then we're going to create an equivalent rational expression using the LCD, right? Then we have to make common denominators. So we're going to figure out what the common denominator is supposed to be. Then we're going to make a bunch of common denominators. And then step 4 says we'll add or subtract the numerators together. And then we'll just simplify it at that point. We'll write it as one rational expression. And then voila, we'll have combined rationals together through addition and subtraction. So let's test your knowledge. So pause the video and try these. So there's 4 examples. Okay. Don't worry if you're wrong. Don't worry if you get stuck. Just try your best. Try to see how well you can go through number 1, number 2, number 3, number 4, and these kind of move up the ladder in difficulty and kind of see where it is that your understanding stops. Okay. So pause the video right now. Try these out. I'll meet you guys back. So hopefully you pause the video. I'm going to go over all 4 of these now. So number 1. Pink may not show up. We'll just go good old black today. So number 1. So how do I add 2/3 with 6/5 and subtract 1/2? So I'm combining all these rational expressions together, right? They're fractions, but fractions are rational expressions. Well, step 1 says simplify if I can. Well, all of these look like they're in the most reduced form they could be. Step 2 says find the LCD. So the LCD of 3, 5, and 2, well, these are all primes. So what I'm going to do is I'm going to multiply them all together. So 3 times 5 times 2. So my LCD is going to be 15 times 2, so 30. So I need to make denominators of 30. So step 3, I need my denominator to be 30. So if I have 2/3, what do I need to multiply 3 by to get 30? Oh, 10. So I'm going to multiply top and bottom of that guy by 10. My 6/5 term, what do I need to multiply 5 to get to 30? Well, I need to multiply it by 6, so this term is going to get a 6 and a 6. Notice how they're different, right? It's not going to be a one-stop shop here. Alright, and then my 1/2 term, I need to get a 30 down here, and I have a 2, so 2 times what equals 30? Well, 2 times 15 equals 30, so I'm going to multiply top and bottom of this term by 15. Okay, so step 4, so we're going to add or subtract the numerators now, so let's simplify this a little bit before we go to step 4. So that'll be 20 over 30 plus, that'll be 36 over 30 minus, that'll be 15 over 30. Now be careful. It's really tempting to be like, ooh, I can reduce all those, but don't do it because you'll end up right back where we started. Okay? Now I have everything over 30, so now I can go to step 4, which says add or subtract the numerators together. So this whole thing is going to equal, let's see, 20 plus 36, that'll give us 56. 56 minus 15. So this is what's happening now. So we're doing 20 plus 36 minus 15. So now we just get to combine all the numerators over the one denominator, right, because all the denominators match. So 56 minus 15, that'll be 41 over 30. And can I reduce that anymore? 41, nope, not divisible by 3, not divisible by 5, not divisible by 2, nope, we're done. So 2/3 plus 6/5 minus 1/2 is equal to 41 over 30. Okay, this is nothing new. We learned how to do this back in elementary school, but we're going to apply this exact same process now to if I have more of a linear or a quadratic or a higher degree polynomial over a higher degree polynomial. So we're going to do the exact same thing. I'm just going to throw x's in now for the next example. Alright, so now I want to add 1 over 9x plus 4 over 5x. So step 1, can I simplify them any further? No, there's nothing I can do here. So step 2, LCD. Well, I have 9x, that's 9 times x. I have 5x, that's 5 times x. So my LCD, I have to take a 9. X occurs once. I only take one of them. 5 occurs once. So my LCD is going to be 9 times 5 times x, which is going to be 45x. Okay, I need all of my denominators now to be 45x. That's my goal. So step 3, how do I make 1 over 9x? How do I make 9x into 45x? What do I have to do to 9x to make it into 45x? In other words, 9x times what will give me 45x? Well, times 5. Okay. And what about 5x? What do I have to multiply 5x by to get 45x? Well, if I just multiply it by 9, I'll get there. So I have to multiply by 9 by 9. Remember, whatever you do the denominator, you must do the numerator, keep it equivalent. Alright, let's clean up. So that'll now be 5 over 45x. This will now be 36 over 45x. Hey, look, now I have my matching denominators. So now step 4 says just combine, add or subtract numerators over 45x. 5 plus 36 is 41. Hey, this shows up again. Over 45x. 41, 45, no common factors. So we're done. We're simplified. So 1 over 9x plus 4 over 5x combines to be 41 over 45x. Alright, let's keep stepping it up a little bit. Alright, now what about this guy? Now I don't just have a monomial in my denominator, now I have a binomial in my denominator. So what am I going to do with this? Same thing. I'm going to run through the same steps. Every single time I'm going to run through the same steps. So can I simplify it? No. Remember, I can't knock those x's out because x minus 8 is the whole factor down here. I can't just knock pieces out, so that's not going to work. Alright. LCD. Well, x minus 1 is as factored as it can be. And x minus 8 is also as factored as it can be. So my LCD is just going to be the 2 multiplied by each other. Sometimes this happens if they don't share any common factors, then the LCD is simply the 2 denominators, or 3, or however many, just multiplied by each other. So there's my LCD. Again, my suggestion is to not multiply it out. Keep it in factored form. It'll actually make things a little easier. So step 3, let's make some equivalent fractions. So if I have 5 over x minus 1, and I need my denominator to be x minus 1 times x minus 8, then what do I need to multiply by? Well, I need to multiply the x minus 8 in there. Right now, that looks like that. Minus x over x minus 8. Sorry, that was written over there. Actually, let me erase that. That doesn't look so good. X minus 8. Okay. Now, how do I make x minus 8 look like x minus 1 times x minus 8? Well, what am I missing? Well, I'm missing the x minus 1 piece, so I'm just going to multiply that in. Look, now I have matching denominators, right? Remember, multiplication is commutative, so it doesn't matter which way I write it. Now my denominators match. Great. let me do some cleaning up with my numerators. 5 times x is 5x. 5 times negative 8 is negative 40. Ooh, minus sign, which means let me use parentheses because I'm subtracting this whole quantity. X times x is x squared. X times negative 1 is negative x. Parentheses are your best friend in subtraction. All this over x minus 1 over x minus 8. Remember, these two denominators are the same. It doesn't matter the order that it's written. So step 4. Now let's clean up this numerator. Let's see. What do we have here? We have a negative x squared. We have a 5x minus, so we have a 5x minus x. So that's going to be plus 6x. And then a negative 40 is out here all by itself. All this over x minus 1, x minus 8. Okay. Now the next thing we want to look for, is there any simplification that can occur here? Well, first off, let me throw that minus out of here. So I'm going to change that positive, which means that'll be negative, which means that'll be positive. And I'm just going to give that negative sign to the denominator now instead. Minus 8. So what I did is I factored out the negative from the numerator, and I just threw it in the denominator instead. Let's see, can this thing get simplified? So factors of 40, we can use 8 and 5, but that's not going to work. We can use 4 and 10, but that's not going to work. 2 and 20, but that's not going to work here because we're trying to get to negative 6. So I actually think we're done. So there we go. There's our combined rational. Alright, last example. So this is the big one. Alright, same thing. So there's no simplifying that can happen, unfortunately. So let's find the LCD. So x minus 6 is x minus 6. So that's the factor here. Factor this guy. It's going to be x minus 6, x minus 4. Negative times negative, positive 24. Negative 6 plus negative 4, negative 10. Alright, so the LCD then is going to be, I'll take that x minus 6, which means I don't need that one, and I'll take that x minus 4. So my LCD is going to be x minus 4 times x minus 6. So it'll look similar to the last problem we did. Now let's make our equivalent fractions. So 5x plus 1 over x minus 6. What do I need to multiply this by to get my common denominator? Well, I need to throw the x minus 4 in there. I throw it on the numerator. 2. There we go. Minus x over, now I'm going to leave this in factored form. It was already x minus 6, x minus 4. So I actually don't need to do anything to this back term because it already is our common denominator. So we're done. I don't need to multiply that by anything. Alright, let's clean up. So let's multiply out this numerator because this is now a binomial times a binomial. So 5x times x gives me 5x squared. 5x times negative 4, negative 20x. 1 times x plus x. 1 times negative 4 minus 4. And then my numerator here, minus x. I don't need parentheses because I'm only subtracting the one term. And then my denominator is still x minus 6, x minus 4. Alright, step 4 says let's clean this up now. Are there any other x squared terms? No, they're not. So 5x squared stays. And then I have minus 20x plus x minus x. Oh hey, plus x and minus x are going to cancel each other out. We already dealt with that. So I'm just going to say minus 20x minus 4. And all this is going to be over x minus 6, x minus 4. Alright, and we have combined. And voila, done. So let's review what we did. So step 1, if you can simplify, but as you saw, that's not always the case. Step 2, find your LCD. So make sure you're really good at finding LCDs. Make sure you're really good at factoring by the time you get to this point. And then step 3 says create equivalent rational expressions. So using the LCD, right, we needed to create common denominators. Okay, we had to figure out, okay, this denominator times what will get me to the LCD, and then we fill it in top and bottom. And then we add or subtract the numerators. Basically, we just combine the numerators together with whatever operations we have. And then we simplify and we write as one rational expression, and then we're done. So thank you guys. I hope this video helped. Make sure that you go and do all your practice so that you can kind of cement everything that you just saw here. If you guys have any questions, please always do not hesitate to ask.